Congratulations to the CCS graduates, and perhaps especially to the parents of the CCS graduates. Commencement speakers are usually chosen with the hope of inspiring new graduates through their accomplishments. But having met a number of you already, I know that you don't need inspiring. You have spark, ambition, curiosity, all the ingredients of success. So instead of droning on about how bright your futures are, I thought that I would combine some things that I've learned from Dr. Seuss, Chumbawamba, and NPR to paint a picture of what a path to success might actually look like. The simple fact that I'm up here as a commencement speaker puts me on a kind of a pedestal or behind a podium. And the fact that I'm a Nobel Laureate would appear to set me apart. I want to be clear that I am also you. Here are three versions of the story that I want to tell. The first, the way Dr. Seuss frames it in the book, Oh, the Places You'll Go. You'll be on your way up. You'll be seeing great sights. You'll join the high flyers who soar to high heights, except when you don't, because sometimes you won't. I am sorry to say so, but sadly it's true, that bang-ups and hang-ups can happen to you. No, that's not for you. Somehow you'll escape all that waiting and staying. You'll find the bright places where boom bands are playing. Perhaps the song Chumbawamba says it more concisely. I get knocked down, but I get up again. I get knocked down, but I get up again. A somewhat more erudite way to approach this concept was covered on NPR recently, and it went viral. Johannes Haushofer, a Princeton professor, posted his CV of failure online. As he describes it, most of what I try fails. These failures are invisible, while the successes are visible. Our society encourages us to build up our CVs and our resumes to show our success. But sometimes listing only the accomplishments doesn't tell the rich path of how you got there. After I heard this NPR story, I began compiling my own CV of failure. It includes the jobs I did not get, the schools that did not accept me, the many, many experiments that didn't work, the papers that did not get accepted to the first, the second, or the third journal that I sent them to, and the many, many grant rejections. Today I want to tell you about just three. I came here to major in biology at UCSB and CCS because I was captivated by B. Sweeney. B was an inspiring, energetic, and persistent professor of biology, and at the time, the associate provost of CCS. My time here was transformative because B insisted that I work in many different laboratories to find out what fit my mind the best, and that's exactly what I did. After short projects in a few laboratories, I landed in Les Wilson's biochemistry laboratory, and I found my passion. I discovered the sheer joy of figuring something out, no matter how small. Working first with Kevin Sullivan and then David Asai, I got to design experiments and come into the lab and test out my ideas. Getting results the same day or the next was really intoxicating. It's like a runner's high, and it kept me coming back for more. I fell in love with that kind of mechanistic thinking that underpins biochemistry. So in my senior year, I wanted to continue having fun, so much excitement from the lab, so I began applying to graduate school. Those graduate applications didn't go so well. Even though I was a Regents Scholar, I'd taken challenging math and science classes, had a 3.87 GPA, my dyslexia made it difficult to do well on standardized tests. My GRE scores were very low. So schools that calculated GPA plus GRE filtered me out. I applied to UCSD, UCSF, Stanford, UC Berkeley, Caltech, and one out-of-state school, University of Colorado. Maybe because it also has the initials UC. When the decision letters rolled in, they were not so good. March 15th, 1983, Letter from Stanford Biology Department. I am sorry to tell you that the committee did not recommend you for admission. March 17th, letter from Stanford Biology Department, a different letter. We are so sorry we cannot accept you for a position. March 24th, Stanford Biochemistry Department. I am sorry, there will not be a place for you. Okay already, I get it. Stanford doesn't want me. March 20th, University of Colorado. You are presently on a waiting list for admission. And then rejections from UCSD, UCSF, and Stanford again. Fortunately for me, 2 schools read the applications without calculating cutoff scores. Caltech invited me to interview. I went down for the interview, and each of the 8 professors that I interviewed with started off with, "Why are your GREs so low?" But after talking to them, by the end of the day, I was offered admission. Then came the letter from UC Berkeley. The admissions committee there also read the applications and accepted me directly. Then they invited me to visit, and it was on that visit that I met Liz Blackburn, who would later become my PhD advisor. Graduate school at UC Berkeley was an amazing time. I met a fabulous group of friends who are still my best friends over 30 years later. And I made a discovery that would lead to the Nobel Prize. Liz Blackburn and I discovered the enzyme telomerase that maintains the ends of chromosomes. I won't detail the many ups and downs that accompanied that discovery, but just trust me. I don't want to give you the sense that it's all about failure. What makes it possible to get back up each time is that sometimes experiments do work, and it gives you that adrenaline rush. And the times when you find out something new that nobody else ever knew before. Even the small discoveries stave off the bite of the failures. After discovering telomerase, I went to Cold Spring Harbor Laboratory to characterize this new and fascinating enzyme. I started my own research group and got to decide what questions were of most interest to me. Our group worked out how telomerase elongates telomeres, and we collaborated with others to show that they play a role in cancer and cellular aging. One of the big outstanding questions at the time was, what are the components of telomerase? There was something of a race between a number of different groups to identify the genes that encode this unusual enzyme. In 1985, my group published a paper in a very high-profile journal stating that we had identified 2 genes encoding the proteins P80 and P95 that were part of telomerase. But it would take us another several years to do the real killer experiment to show that this was true. In the meantime, another group identified a gene now called TERT as the gene for telomerase. Their evidence was overwhelmingly strong. I was convinced that they were right. Could we be wrong? Around that time, the assistant director of Cold Spring Harbor Laboratory asked me to meet with him. He looked me in the eye and he said, "Carol, how can you ever recover from this? You've made a big mistake." It brought me to tears. I was knocked down. Then I got up to set out and find out what was wrong. I needed to know the truth. It took some time to find the problem, but in 2001, we published a paper entitled, "P80 and P95 are not components of telomerase." Now I had closure. We had made an error, and then we corrected the literature ourselves. In the meantime, my lab went on and made other important discoveries, further connecting telomerase to age-related degenerative disease. Playing the grant game in biomedicine really requires the ability to get back up again. Typically, I'll spend 2 months writing a grant proposal, send it off, wait 5 months to know how well it scored and whether I would receive funding. When a grant comes through, I'm elated. When it's not funded, I allow myself to mope for a few days, and then I get back up. One particular story of a bad grant score has a bit of a twist to it. October 5th, 2009, the grant proposal I had sent in 5 months before was to be discussed at the National Institutes of Health at a meeting of 20 of my peers. The reviewers had written their reviews before that meeting. At 5:15 a.m. on October 5th, I received a phone call from the Nobel Committee stating that I would share the Nobel Prize in Physiology or Medicine with Liz Blackburn and Jack Szostak for the discovery of telomerase. The press calls began at 5:45 a.m. NPR covered the news on their morning edition, as did many other news outlets. The NIH Grant Review Committee convened that morning at 8 a.m. And when my grant came up, it was triaged, that is, not worthy for discussion. So, the summary statement from that grant reads, strengths. This is a clearly written proposal that describes work to induce telomerase to treat disease. Weaknesses. The only major weakness is the limited preliminary data presented in support of the aims. So even on the day when your Nobel Prize is announced, skeptics may still wonder whether you really know what you're doing. I never did get that grant. But the consolation prize was I got to go to Stockholm in December. So, I know that you all already know everything that I just told you. When you get knocked down, you get up again. That's what commencement speeches are about, telling you what you already know. But perhaps through telling you these stories from my life, you may see your own falls in the humorous light that I now look back on mine. And maybe it will reinforce your desire to get back up quickly, because when you do, you open yourself to so many possibilities. Thank you.
You know, I have heard hundreds of commencement speeches. And if you can find another more inspiring speeches than this one, please let me know.